NovaSAR is a new satellite that we've developed for radar monitoring. It's the first radar satellite that we've built, and it takes a new approach to radar, and it combines that with our small satellite approach to bring us a new capability for doing radar at a very different price point.
It was designed from the beginning to meet three key applications: environmental monitoring, particularly in forestry, disaster monitoring and management, and maritime.
There's actually 4 microwave frequency bands you can use for imaging the Earth from space: L-band, S-band, C-band and X-band. And images from all of them can be used for a wide variety of applications. Although our choice of S-band for NovaSAR was driven by technology, we wanted to use the most up-to-date amplifier technology for the highest efficiency to produce the high-power radar pulses. This allows us to build a smaller satellite at lower cost.
The biggest challenge was to find a way to get the cost down dramatically while still achieving useful performance, and that is really about the design of the antenna of the radar. There are different styles of antenna, like reflectors and what's called a phased array, which is a rectangular structure with multiple repeated elements. If you have the latter, then you have the ability to steer and shape the radar beams, and that gives you the opportunity to implement lots of different modes.
ScanSAR is NovaSAR's default mode. It offers a medium resolution of approximately 20 metres and a swath of 50 to 100 kilometres. We also offer a slightly wider ScanSAR wide mode. Our highest resolution mode is the strip map mode, which offers 6 metres of resolution and a narrower swath. And finally, we offer the maritime extremely wide swath up to 400 kilometres over open ocean for ship detection. A key application of NovaSAR will be in disaster monitoring. One of the key advantages is that we can see through clouds. Following a hurricane, for example, when the area is still covered by dense cloud, traditional optical satellites can't see through. We will be able to see the ground, perform flood impact assessments, but also help with very quick response, immediate imagery of the disaster area to help with the relief effort and planning. Another application is that it can look at the soil moisture and identify areas which are prone to flooding. And in that way you can identify areas that are at risk, focus your mitigation efforts on particular areas that are the highest risk of flooding. Combining AIS and SAR data will allow us to provide information to shipping, customs and fishing authorities so that they can monitor their areas of interest and see any illicit activities, for example illegal fishing or illegal transportation or smuggling.
I think the future does look bright for NovaSAR. We've had a lot of interest in NovaSAR.
Traditionally, the low-cost Earth observation has been done with optical satellites. What we are doing now is actually evolving that into synthetic aperture radar, and this is actually securing the place of the UK to actually have the next big step in Earth observation.